let's look at the inverse of the quadratic function. So recall the quadratic parent function is f of x equals x squared. And we're going to start by looking at its graph. So let's create a table of values for y equals x squared. We'll have negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. And we'll plot these ordered pairs. So 0, 0, negative 1, 1, 1, 1, negative 2, 4, 2, 4, negative 3, 9, 3, 9. And if we sketch in the curve, we now see our parabola shape opening upwards. Okay, now let's look at the inverse. And if you recall, if we're given a table of values, we can find the inverse by swapping the x and y values in the table. So instead of negative 3, 9, we'll swap them around and get 9, negative 3. Negative 2, 4 swaps around to become 4, negative 2. Negative 1, 1, swapping the values, we get 1, negative 1. 0, 0, if we swap them, it stays 0, 0. 1, 1, if we swap them, it stays 1, 1. 2, 4, swapping them around, we get 4, 2. And 3, 9, swapping them around, we get 9, 3. So now let's plot these points in red. And we see that those points on the graph. And now if we fill in with the curve, we get the graph of what looks like to be a sideways parabola. And this looks like it's our inverse to our parent quadratic function. But this graph in red does not pass the vertical line test. So that means our graph in red, our inverse, is not a function. Now, often though, when we talk about inverses, we prefer to talk about inverses that are functions. So let's see if we can make this red graph into a function. And we can do that by erasing the bottom half and only considering the top half of this sideways parabola, because the top half of the sideways parabola passes the vertical line test. Okay, so now our sideways parabola, the graph in red, that top half, the domain is from 0 to infinity, including the 0. And its range after we erase the bottom half is also from 0 to infinity, also including the 0. And in our table, we're going to ignore those top values since those belong to the points that we erased. Now, if we're looking at the graphs, if you recall, inverses are reflections of each other over the line y equals x. And now that we erased the bottom half of our sideways parabola in red, these graphs, the green original graph and our red inverse graph, are not reflections of each other over the line y equals x. And let's see if we can make them reflections of each other. We can if we only consider the right-hand side of our quadratic parent function. So I erased the left-hand side. And now our green graph and our red graph are reflections of each other over the line y equals x. Now, our original quadratic parent function had a domain of all real numbers, but our graph that we have here in green has a domain from 0 to infinity, including the 0. And our range stays at from 0 to infinity, including the 0. We're going to ignore the top half of the values in our table because those belong to the values that we erased. And we essentially restricted our domain of our original function. So instead of considering the whole parent function, we considered just the part of our parent function where our domain is from 0 to infinity. We are not including the part of the parent function where the x values are negative. One important thing to note, which may not be completely obvious given our functions here, are that the domain of a function is the range of its inverse. And the range of a function is the domain of its inverse. Okay, y equals x squared. Let's remember how to find our inverse algebraically. We're going to swap x and y, so I get x equals y squared. And I want to try to get y by itself. So to undo the exponent of squaring, the inverse operation is taking the square root. So if I take the square root of both sides, I get y equals plus or minus the square root of x. Well, this is not a function. And in order to only consider an inverse that's a function, we will ignore the negative part and only consider y equals the square root of x.